travels outward at a speed of 60 centimeters a second. What's the what equation do you want to work with? Pi r squared? Yeah, we want the area of the circle. Area equals pi times radius squared. So the rate of change of the area is equal to what? 2 pi r. So it's asking find the rate at which the area within the circle is increasing at 1, 3, and 5 seconds. So a prime of 1, a prime of 3, and a prime of 5. So what's it going to be? 2 pi, 6 pi, and 10 pi. What are the units on this going to be?
Centimeter per second?
Nope. Area is not measured in just centimeters. Centimeters squared per second. Correct. There it is. You just did your first related rate question. Oh, I'm so proud of you. Yeah, you can multiply the square root through. So you get s is equal to 3t to the what power? 5 over 2 minus 35t to the what power? 3 over 2 plus 90t to the... It looks more complicated, but it's a lot easier to find the derivative. Can someone just tell me what the derivative is? What's s prime going to be? Which is v of t. 15 over 2 t, 3 over 2, minus 105 over t to the plus t to the... So there's the velocity right there. What's the velocity at after 3 seconds? That's just v of 3. 15 over 2, 3 to the 3 halves, minus 105 over 2 times 3 to the 3 halves, plus 45 times 3 to the negative 1 half. There's the velocity down. Could you type that into your calculator and get a numeric answer? Sure. Is it going to be a nice fraction? No, it's going to be an irrational number. You're rooting 3. The square root of 3 is an irrational number. Okay, so that's A. Oh, sorry, that's B. So we had A, and then B, and then it says, when is the particle at rest? How do you figure out when a particle is at rest?
Set equal to 0.
You set it equal to 0. You set what equal to 0? Yeah, so you take this, you're solving this is equal to 0. Now what are you going to have to use in order to do this? That's not a polynomial, that's not a quadratic. What are you going to have to do? In order to solve this equation, what are you going to have to use? Oh, come on. What do you have to use? Graphing calculator, thank you. Do you have any way to do that by hand? Seriously, there really is no cool way to do that by hand. It's not a polynomial. You're not going to factor that nicely. You use your calculator. Use your calculator right now and tell me when that's equal to 0. Use your calculator right now and tell me when that's... How do you find the total distance traveled in the first 8 seconds? No. You find out where the particle is when it starts, and then you find out where the particle is when it is equal to what? We talked about this yesterday. When you go out 10 miles and come back 10 miles, how far have you gone? See, 20 miles. So you need to know where you are at the turnaround point. So what are the turnaround points? We just found them. 1 and 6, and then what's our end point? 8. So you find the position at each of these times. You find the position at each of these times. The original position function is right here. So you take this position function right here, and you just fill out this table and go from there. So do that for me right now. Find me the position at these 4 times right here. Find me the position at these 4 times. Nope. What's this distance traveled? 58. What's this distance traveled? It's 58 plus 29.39. And then what's this distance? 0.39 plus 5.65. You add them all together. Someone do that for me right now. This is 3.3. What number is this? 6? Number 6. Oh, cool. Yeah, they are. It is exactly 1 and 6. Cool. 180.44. There it is. Here is that. Here it is. Cute. Look how they factored that thing. Ew. That is so awful. But do we agree with their answer? 180.44? Yeah. Good. Check out the math that they did on this one. So did they get the same derivative we got? And then they just factored it, which is okay, but would I ever, I mean, theoretically, for me personally, this is not how I would do it, and I've done thousands of these. I would look at that and go, screw that, I'm using the calculator. Seriously. If the only reason I would attempt to factor that would be if it specifically was on a section that did not allow a calculator. The only reason I would try to factor that. I mean, look at that. Does this look like something you'd ever want to factor? No. No, not at all. It's ew. Ew. Don't. So if you have a calculator, please use it and just find 1 and 6. And look, when you get exact answers like 1 and 6, what does that tell you? There was probably an easy way, but here's the thing. This is the easier way. Is this? Do you judge this as easier? Like, would you have known to look for 1 and 6 if you hadn't used your calculator? No. No, not at all. That's annoying. Because that's kind of like hindsight is 20/20. They're like, oh, by the way, you should have done it this way. We only know to do that because it was set up that way to be ugly. Oh, well. This right here is an important part. I want to blow this up a little bit. Oh, wrong one. This is the diagram. You don't generally have to draw these, but I like having them. This is a visual representation in a way of what we just did. Let me show you. So at time equals 0, the position is 0. At time equals 1, it's 58. And then it goes all the way back to time equals 6, has a position of negative 29.4. And then at time equals 8, it's here. So that's how you can visually represent what's going on. The particle's just moving back and forth. That's it. It's not that bad. Okay, any others from the homework? Anything else? 26?
Yeah.
Okay, cool, okay. You like these real world problems? Kinda? What, butsuo? Is that how you say? Oh, you're Korean. I'm sorry. I don't know how to say that. Oh, she's angry now. You know what a really easy way to get people angry is? It's like totally disregard where they're from and confuse it with another country that's right next door. It's really fun. You're German, right? See, that's not funny because it's like, obviously I'm not German. But you know, maybe you are, so who knows?
So in my class told somebody from Belgium that they were from Belgium, Germany. Yeah.
Belgium. Oh, Tomas? He's awesome. I love that guy.
So funny.
Oh, he convinced somebody he was from Belgium, Germany?
No, he was like, I'm from Belgium, and then we were like, we were introducing
Yeah.
ourselves, and then she was like, she had to go around saying like one
Yeah.
thing, whatever. She was like, he's from Belgium, Germany. He was like,
The thing is, he has to be used to that because even like well-educated people, like, can you tell me the 3 countries that are all in the same area of Belgium and what languages they speak?
Spain,
The countries, what are they called?
the Netherlands.
Which has the same name as it's the other. The Netherlands and Holland. They are the same place, right? Does that mess things up?
Yeah.
Yes. What do they speak in Belgium? Yes, but what does Tomas speak? Flemish. Guess what that's a name for? Dutch. Okay? It's all very, very, very hard to keep straight, okay? I'm not kidding. Like last week, Pops was explaining it to me. I'm like, huh, I feel ignorant. Yeah. Yeah. It's weird, huh? It's fun. No. He's very cool, though. Okay, maybe I want to speak Dutch and French and English. I'd take that. That'd be cool. Suppose that a bacteria population starts with 500 bacteria and triples every hour. Okay, we can do this. So the population P, and it triples every hour. So every hour you multiply it by 3, correct? So the population is going to be the initial times 3 to the what power? N, where N is in what? Minutes? Seconds? Hours. What happens to the initial population? This represents the... Oh, so instead of A, what could we write? I'm sorry. A was the initial population. 500. Every hour, what happens to the initial population? It triples. There it is. There's your equation. What is the population after 3 hours? So what's the population after 3 hours? 500 times 3 to the... So that's going to be 27 times 500, which is what? Don't use your calculator to figure this out. 13,000 what? 13,500. You don't need your calculator to multiply 27 by 500. Use 5 in section 3.1 to estimate the rate of increase of the bacteria population after 6 hours. You can actually do this now because I told you how to find the derivative of this. You need to find P prime.
So it's 500.
It's going to be 500. No, it's not 500n. 500 times 3 to the n times what? Natural log of 3. Remember that? I told you this already. I bumped this ahead. The derivative of a to the x is ln a to the x. What's the derivative of e to the x?
E to the x.
E to the x. Exactly.
Natural log of e.
Ah, what rule? Quotient rule. Low. What's the derivative of the top? What's the derivative of sine? So low d high minus high. What's the derivative of the bottom? Negative sine x. I just told you that all over what? Cosine squared x. Well, that's cosine squared x plus sine squared x over cosine squared x. What's cosine squared plus sine squared? So that's 1 over cosine squared x, which is 1 over cosine x squared. So that's what? Secant squared x. So you just figured out that the derivative of tangent x is equal to secant squared x. Oh, cool. That's tangent. Okay, do this for me. Find me the derivative of cotangent. Find me the derivative of cotangent using a very similar method. Find me the derivative of cotangent.